Okay, so time for another theorem. So suppose here that u here is a function of x and v here is also a function of x. Sometimes we would write as u bracket x close bracket or v. Sometimes we can write it like this. Sometimes we can just say, oh, this here is a function of x. So this here is the same thing as this. Okay. Yeah. Sometimes we could write we could say this here. But sometimes we can just leave it as this. So here, suppose you want to differentiate this here. If you have a sum of two things, you can just concentrate on differentiating this one, and then add it to the differential of this one here. So suppose you have something like this here. Differentiate this whole thing here. Then you can just concentrate on differentiating this one, which will be, remember, this goes down here, so it will give you 6 x, and then the 2 gets minus 1, so that will leave you with to the power of 1, which is just x. So now this one here, this times this here, so this would be 10 x to the power of 4. Okay, so what this is saying here is that if you want to differentiate the sum of two things here, just differentiate one and then add it to the differential of the other one. So here, just concentrate on differentiating this one and then differentiate this one and then add the two together. In the past, I would give you in the past I gave you some exercises on this here. Suppose you find I would give you something like this. Find find dy by dx of this whole thing here. I would then ask you to just quickly sketch this graph here. So when x is small, it wants to do this here. So it will have an intercept of 3 here, and then it will have a gradient of positive 4. So I would ask you to do something like this. When x is big, it wants to do this positive quadratic. So it wants to do this thing here. So now, so you would guess the graph to look something like this, and then set up points A and B here, and then we would jump to this here. So in the past, for us to evaluate the dy by dx of this thing here, we would have to follow this whole process here. Remember this thing here? Dy by dx equals the limit as h tends to 0 of f of x plus h minus f of x, and then divided by h here. So we always rely on this to work out the gradient of something. So in the past, for us to work out dy by dx of this, we would have to jump to this whole thing here, and then we have to multiply everything out. So square this and blah 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 blah, and then do this minus this minus this, and so on. We had to follow through all. Well, we would blah 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 all the way down here, and we would get to dy by dx equals 6 x plus 4. Now, with our new theorem here, so with our new theorem, suppose we had to work out dy by dx of this one here. With our new theorem, this is our theorem here. If you want to differentiate two things here, then just concentrate on differentiating this, and in fact, we could extend this theorem. We could make it 3 parts here. For example, we could say this as well: u plus v plus w, and then that equals du by dx plus dv by dx plus dw by dx. We could extend it. So here we've got, in effect, this thing is, in a way, it's like our w earlier. This is our u, this is our v here. So if you want to work out dy by dx, then dy by dx would mean you trying to differentiate this, which will be 6x here, and then add it to this, add it to the differential of this here, which is 4. And when you try and differentiate 3, that's plus 0. If you draw a graph of y equals 3, the gradient of this line here is 0. So the gradient of this is 0. The gradient of this is 4. The gradient of this is 6x. So this equals 6x plus 4. So same as earlier, but a lot easier. Oops, this is dy by dx. A lot easier. So so going back to our original question here, hang on. So if you want to work out the dy by dx of this thing here, rather than doing all this here, working all this out here, we could just do it in one go. So dy by dx equals this bit here will be 6x, and then this bit here will be 4. So dy by dx equals this. Okay.